A child whirls a stone in a horizontal circle 1.9 meters above the ground by means of a string 1.4 meters long. The string breaks and the stone flies off horizontally, striking the ground 11 meters away. What was the centripetal acceleration of the stone while in circular motion? So from a top-down view, that could look like this. This is a circle, and the stone is maybe right here in its path. This is the center, and some radius r. Now from a side view, we can graph the trajectory of the stone. So it starts like this with a rightward speed, and then goes down like this. This distance is some L, and this is H, both of which were given. Now, from this, we're trying to find the centripetal acceleration that was there during the circular motion. Well, we know that the centripetal acceleration is equal to the velocity squared divided by the radius. And we know the radius, so all we need to do is find the tangential velocity during this, or the tangential speed during this circular motion. Well, that's where this part comes in. We can find the speed of the stone when it was like this. It started with some speed v, and it fell like this. Based on these, we can find the initial speed of the stone. How though? Well, once we have the time, we can find the speed of the stone because this distance divided by the time is equal to the velocity, or the speed. And how do we find the time, you ask? Well, using this part, using this dimension. It starts with an initial vertical velocity of 0. So we can use this kinematic equation, t plus 1/2 at squared, for the vertical dimension. So delta x in this case is negative h. I'm assuming upwards to be positive. And the initial velocity is 0 because we're just considering the horizontal dimension. The vertical dimension. So that's just not there. 1/2. The acceleration is negative g and time squared. Solving for time, we get that this is the square root of 2h over g. So now we plug that into this. So the velocity, or the speed, is equal to L over the square root of 2h over g. And now finally we plug this into this. So centripetal acceleration is equal to this giant thing divided by the square root of 2. This is going to be really small, but this is just v squared divided by the radius. So now all we have to do is plug this into a calculator, and we get the centripetal acceleration is equal to 220 meters per second squared.